Our Tennessee State Standard today is to give examples of linear equations in one variable with one solution, infinitely many solutions, or no solutions. Show which of these possibilities is the case by successively transforming the given equation into simpler forms until an equivalent equation of the form x equals A equals A, or A equals B results, where A and B are different numbers. Your lesson objective that you need to pause the video and write down. I am learning to determine whether an equation has one solution, infinitely many solutions, or no solution. Now, this is just a review because we've already covered these steps to solve multi-step equations. Step 1, we box in the terms inside the parentheses and multiply each box by the number outside parentheses. All right, so you're going to have to take a few minutes to pause this and write this down. Step 2, we combine like terms. Now remember, you look at the left side for like terms, then you look at the right side for like terms. Like terms do not cross the equals sign. Number 3 is to eliminate a variable. So you choose a variable, whether on the left side or the right side, and when we eliminate, that's when we do the opposite. In step 2, where we combine like terms, we look at one side, and combining is actually adding the terms. So we eliminate a variable. Step 4, we eliminate the constant that's on the side with the variable. All of these you've had before. Step 5, you're going to divide by the coefficient, which will give you your solution. And step 6, you're going to check your solution. So take some time and write these down in your notes. All right, so compare and contrast the following equations. Well, they both start with 2x plus 4. And we're going to use the distributive property on both of them. But the difference I see is that this parenthesis has x plus 1. This parenthesis has x plus 2. So let's just use our steps to solve these two equations. And I'm going to draw a line down through there so you can see they're two separate equations. So step 1 says to box in your terms inside the parentheses. So I have parentheses on the right side. So I'm going to box in my terms and then I multiply by what's outside. 2 times x is 2x. 2 times positive 1 is positive 2. Everything else equals, and the other side of the equation comes straight down because we did nothing with those. Now, some of you may be seeing something that has you a little bit confused, but if not, you're not seeing that yet, let's just keep going. So, step 2 is to combine like terms. I have a variable and a constant, so no like terms on the left. Variable, constant, no like terms on the right. Now, I'm going to box in my terms just because it makes it simpler to see. So now we have step 3 that says to eliminate a variable. So they're both the same. So if I subtract 2x on each side, both of those go away, and that leaves me with the equation, not really an equation, 4 equals 2. And since we know that 4 does not equal 2, this equation has no solution. So there is nothing, because if you look, after we distribute 2x plus 4 equals 2x plus 2, there is nothing that we can put in for 2x or for x that will make these two sides of the equation equal. Now let's do the second equation. We box in our terms, and multiply by what's outside. 2 times x is 2x. 2 times positive 2 is positive 4. Everything else comes straight down. Now you may notice that equation looks the same on both sides now. We're going to keep working just so that you can see it worked all the way out. We're going to do exactly the same thing. We look for like terms, variable, constant, no like terms on the left, variable, constant, no like terms on the right. So we eliminate a variable. When we eliminate that variable, eliminates both the variables, and we end up with the equation 4 equals 4. Now, you do not, if you realize that this equation is the same at this step, 2x plus 4 equals 2x plus 4, then that tells you that no matter what value you substitute for x, it is going to satisfy that equation. So this equation has infinitely many solutions. And we've already talked about how the solutions of the two, well, we've not. The solutions differ because the first equation on the left has no solution. There's no value that you can substitute in for x to make that equation balance. The equation on the right, any number that you substitute in for x will satisfy that equation. And if you don't believe me, pick a number, plug it in for x. So let's say we used the number 2. 2 times 2 is 4 plus 4 is 8. 2 plus 2 is 4 times 2 is 8. So any number you choose will satisfy that equation. So far, up until today's lesson, when we solved linear equations with one variable, we found one value of x that would make the equation a true statement. However, sometimes when you transform equations to lowest terms, you find that they don't have just one solution. They may have no solution. They may have many solutions. So the 3 types of solutions for linear equations in one variable, you need to write these down on your notes. You may have one solution. Those are the ones that we're experienced with. You may have no solution where there's no number will satisfy the equation that you can plug in for x to satisfy the equation because the equation is imbalanced. And finally, there are infinitely many solutions because any number you choose will satisfy the equation and keep it in balance. All right, so step 1, we're going to box in our terms inside the parentheses and multiply by what's outside. 2 times 2x is 4x. 2 times negative 1 is negative 2. Everything else comes straight down, so that's minus 3 that equals 4x minus 5. I'm going to box in my terms again. Draw the line in front of the sign. On the left side, we have a variable and a constant, so no like terms. Right side, we have variable, constant, constant. So we can put our constants together. Negative 2 minus 3 is negative 5. The 4x comes straight down. And as you can see, 4x minus 5 equals 4x minus 5. If we keep going, then we would subtract 4x. And that would leave us with the balanced equation of negative 5 equals negative 5. So this solution is infinitely many solutions. And that's how you will answer, infinitely many solutions. All right, box in your terms inside the parentheses and multiply by what's outside. 4 times x is 4x. 4 times positive 2 is positive 8. If we subtract or eliminate a variable, we subtract 4x. That leaves us with 2 equals 8, which is not true. So that tells you there is no solution. Now, I'm fine with if you realize up here 4x plus 2 equals 4x plus 8, you can stop right there if you realize there's nothing that will satisfy that, because your variable term is the same, but your constant term is different. So you can stop right there. Okay, let's box in our terms. We have no parentheses. We have no like terms on either side, so we need to eliminate a variable. Let's subtract 2x. 5 minus 2 is 3x minus 8. You'll know how to go ahead and solve this. Box in your terms, and we're going to eliminate the constant on the same side as the variable. That leaves us with 3x equals 9, and if we divide by 3, we get x equals 3. So 2 times 3 is 6 plus 1 is 7, and 5 times 3 is 15 minus 8 is 7, so we know that checks. All right. Box in the terms. There are no parentheses. Variable, constant, no like terms. Constant, variable, no like terms. Let's get rid of a variable. And this would be no solution. All right, let's box in terms inside the parentheses. 3 times 4x is 12x. 3 times positive 3 is positive 9. Everything else comes straight down. Minus 2 equals 12x plus 7. Now we have to combine like terms because we have 3 terms on this side, so that tells me something's alike. We have a variable, constant, constant. So if we put our constants together, 9 minus 2 is positive 7. And at this point in time, you should realize that both of the sides of the equation are the same. So that means we will end up with infinitely many solutions. And that is the end of our lesson today.